Yo, this is Coach Ray back on the mic, ready to teach you some difference of perfect squares. Here we go. Let's start with the title. Okay, difference meaning subtraction. Every single one of these problems is subtraction. So you can see example 1 and example 2, they both have subtraction. It has to be that way. If it were a plus sign on these types of problems, it would not be factorable. So it has to be subtraction. That's why we say difference. Okay, perfect squares. A perfect square is a number like 16, where if you multiply something by itself, it equals that perfect square. Here's where the term came from. If we draw a perfect square, as best I can anyway, if the area was 16, if it's a perfect square, that means its dimensions are 4 by 4. Okay, so perfect squares, 1, 4, 9, 16, 25, 36, yada yada. Okay, so that is what we were looking for. We were looking for 2 perfect squares, and then they are being subtracted. So in example 1 here, we have x squared, so something times itself is x squared. We have 16, something times itself is 16. Okay, so this is a difference of perfect squares problem. What I have to emphasize to you the most is this. Your factoring test is just going to have a bunch of problems on it. You're going to have to look at each individual problem and say, oh, that's one of these types of problems where I do this. Oh, that's one of these types of problems where I do this. Okay, and it's different depending on how the problem looks. So how these problem looks, 2 terms, right? Something minus something. It's got to be a minus in there. And you need to look and see, are they both perfect squares? All right? So if you recognize that this is a difference of perfect squares problem, the problem gets very easy. Hardest part is recognizing what type of problem it is. Okay? All right. The formula up here, a squared minus b squared is equal to this. Let me explain what I mean by that. In example 1, and this is a very basic example, they get harder. Okay? But I'm going to start by just figuring out what's being squared, and then I have minus what's being squared. Okay? In order to get x squared, that is x squared. Okay? What is being squared here? 4 is being squared. All right? And what I've just figured out is I figured out what's being squared and what's being squared. Up here in our formula, that's called a and b. First one's a, second one's b. All right? So my answer, what I do with a and b is this. I add them, and I subtract them. And I'm done. Okay? So step 1, identifying that it's a difference of perfect squares problem. Step 2, figuring out what's being squared, what's being squared. Step 3, add them and then subtract them. You have 2 binomials. Okay, I want to show you this. God bless. I want to show you this. We could do this problem using our old area model. Okay, I could put my x squared right here, and that's probably going to be x times x as my dimensions. I could put my negative 16 right here, so that's probably going to be 4 times 4. I'm going to do my signs last. I can now figure out what the area of these 2 rooms are. This is going to be 4x. This is going to be 4x. And here's what I'm trying to accomplish. I need those 2 4x's to combine to equal 0x. Because notice in the problem it was x squared minus 16. So basically x squared plus 0x minus 16. All right, if I make one of these negative, oops, whoa, that was weird. Okay. If I make one of these negative, so then this would be x times negative 4. Now those 2 will cancel out. What I have is x squared. I've got plus 0x because those 2 cancel out, and I have minus 16. So there's my answer: x plus 4 and x minus 4. Okay. So if it's a difference of perfect squares problem, this always happens. These 2 always cancel each other out. All right. So as long as you recognize it, we don't need to waste time on the area model. We can just get right to writing down our answer. Okay. All right. A little bit harder one. I'm going to start by figuring out what's being squared minus what's being squared. Okay, first one's pretty easy. To get 9, 3 is being squared. Over here, to get 25, 5 is being squared. And in x, 5x squared would give us our 25x squared. Everybody's okay with that? All right, so let's write our answer. Add them and subtract them. 3 plus 5x times 3 minus 5x. Far so good? Okay, let me give you the hardest possible problem I can give you. All right? Example 3 is as hard as I can make it. and it looks worse than what it is.
Wait, can you please not explain it yet? I want to try to do this.
Okay, something's being squared minus something's being squared. Let's start with the number. 36. So clearly that's going to be a 6 is being squared, yes? Okay, something times itself equals x squared. Okay, that's x. Piece of cake. Alright, off to the side here. Something times itself equals y to the 6th. Any guesses?
3. Y to the 3rd.
Y cubed. And check this out. I never teach exponent rules. I never tell a kid, oh, when the bases are the same, you add the exponents, or when the base. I never teach kids that because kids never remember that. Instead, it should all just make sense. Watch this. This is how I literally visualize it every time. Y cubed is y times y times y. Yes, you knew that when you were in like 3rd grade. Okay? Times, dot in the middle, y cubed. Y times y times y. Y times itself 6 times is just y to the 6th power. Okay? This should just make sense. Alright, let's get rid of our scratch work here. Alright, okay, so I've got y cubed. If I were to square that, there would be a total of 6 y's. Good. Alright, in this one, to get 144, that's probably a 12.
Yes.
To get z to the 8th, something times itself equals a total of 8 z's.
4.
So that's z to the 4th power. No. So now I know what's being squared. I know it's being squared. Piece of cake. I'm going to just write my answer down. First one is all of this, 6x y cubed. Okay, and then I've got 12z to the 4th, and I'm going to add them. And minus, oops.
I could have did that by
12z
myself.
to the 4th. Looks fancy. It makes us look smart. A piece of cake. Just figure out what's being squared, figure out what's being squared, add them, and then subtract them. That's as hard as I can get. You okay with that? Yeah?
Besides absolute value.
Alright, I'm going to go, you know what, I'm going to stop this video and we'll do a separate video for the other one. See how I'm looking for my notes?
You walk to your desk.
Well, that means I'm looking for my notes.
Yeah, but